Good afternoon, my name is Larry Cooper, and today we have a problem involving parabolic motion. Let's get started. I'm going to read the problem and then we're going to work through it step by step. Okay, a basketball player attempts to make a basket from a distance of 8 meters. The basket is 3 meters high and the ball leaves his hand from a height of 1 meter. If he throws the ball at an angle of 45 degrees, what does the initial velocity of the ball need to be? Okay, so first, we're going to find out what variable we're solving for. So right here it states that we need to find the initial velocity. So we're also going to list all the other variables they give us. So they give us a distance of 8 meters. So I have right here on the picture, I have the distance of 8 meters from the basketball player to the basket. They also give us the height of the basket is 3 meters high and the height of the player is 1 meter. Okay, so right here we have a diagram showing all of those variables, and we also have the angle theta right here, which is very important, 45 degrees. So we see that the initial velocity is what we are looking for. So with that diagram, we see that the actual trajectory is a parabola, and this is the equation that denotes that trajectory. It's y is equal to y initial plus vi initial in the y direction times t plus 1/2 g, which is gravity, times t squared. We also have an equation for the initial velocity in the x direction. Remember, this is a vector in the vector of the velocity in the x direction, and this is a vector of the velocity in the y direction. So we have v initial times cosine of 45 degrees, and we also have v initial times sine of 45 degrees. Now, if you remember from algebra or trigonometry, you'll remember that cosine of 45 degrees is actually square root of 2 over 2, and so is the sine of 45, which is also actually square root of 2 over 2. And our last equation right here that's very important is the velocity in the x direction. See, right here, gravity doesn't affect a moving body in the x direction, and because we don't have since we set this as our initial point or the origin, there's no initial x coordinate. So right here, all we need to do is solve for t, because if you notice, there's a t relationship between all of these equations. We solve for t, we plug in the 8 right here. We get 8 over the square root of 2 divided by 2, which is 0.707 if you plug that in your calculator, times vi. So we've done all the hard work. Now the easy work is also just basically plugging in and solving for the unknown variable. So right back here, the height of with 3 meters, which is the height of the basket, we're going to plug in right here. Okay, so we got 3 equals the initial height of the player, which is 1, plus, going back here, v initial y is 0.707 vi times t, which we solve for right here, which is 8 over the 8 over 0.707 vi. And as you can see, all of that cancels out, plus 1/2, which is gravity, which is 9.8, but because it's going down, it's negative 9.8, times the time squared, which we have right here, 8 over 0.707 vi quantity squared. If you do all the calculations, manipulations with the math and everything, you're going to see that you're going to come out with 624 over 6. You take the square root of both sides, you're going to end up with a final initial velocity of 10.2 meters per second. So we've done all the computations with step 4. Now we're going to review everything to make sure we did everything correctly. Okay, so if we go back over the equation, we see that we have the angle 45. We solve for both of those to get our velocity in the x and the y. We substitute it so that we could basically cancel out all the other variables and only solve for vi. And so we get a 10.2. And if you really think about it, if you're at a 3-point line and you take a shot and you realize you're about 8 meters away and it takes about a second, well, it kind of works out when you think about it logically, because this couldn't be 100 miles an hour, 100 meters per second. That'd be too fast. So you know you're on the right track because it kind of makes sense. Okay, so I would like to leave you with a quote. Mathematics is not just figuring out x, it's also figuring out why. Thank you.